Hi friends, in this tutorial series, we'll be implementing Spring Boot 3 and gRPC examples. In this tutorial, we'll be looking at what is gRPC deadline and how using it makes our application fail fast. For this, I'll be taking reference of my website javanews.com. So go to Spring Boot 3. In Spring Boot 3, go to Spring Boot 3 gRPC examples. The gRPC example that we'll be looking at today is Spring Boot gRPC deadline example. Let us consider a scenario where we have implemented a gRPC client and a gRPC server. Now, due to some reason, the gRPC server, it is taking a lot of time to process the incoming request. Also, in some cases, the gRPC server, it is not returning a response at all. So in this case, how will the gRPC client behave? According to the gRPC documentation, the gRPC client, it has no default timeout. So the gRPC client, it will keep on waiting indefinitely for the response to arrive. Now, this is not the behavior that we want. We want our solutions to be fail fast. This is where the gRPC deadline, it comes into picture. In this tutorial, we'll be implementing gRPC deadline for gRPC client, using which we specify that the gRPC client, it should wait only for a limited amount of time, else it should throw an exception. So the gRPC client, it will not wait indefinitely for the server to respond. If after some time the server it is not responding, the gRPC client, it will throw an exception. This helps the gRPC client from waiting forever if the server is taking too long to respond. Using a gRPC deadline, it can be useful in scenario. Using a gRPC deadline, it can be useful in scenarios where timely responses are critical. For example, in a real-time messaging application, setting a deadline ensures that the users, they receive proper responses. Using a gRPC deadline, it can be useful in scenarios where timely responses are critical. For example, in real-time messaging application, setting a deadline, it ensures that the users, they receive the responses quickly without expiration. For example, in a real-time messaging application, setting a deadline, it ensures that the users that in a real-time messaging application, setting a deadline, it ensures that the users, they receive the responses quickly without experiencing delays. So even if there is some exception, the user will come to know. It is not that the user, he will indefinitely wait for the response. Also gRPC deadlines, they help manage network resources efficiently by preventing connections from being tied up indefinitely waiting for a response. So if there is no response, then the network, it can release that particular resource. Ultimately, gRPC deadlines help improve the overall performance and responsiveness of the client-server communication. Using a gRPC deadline, it can be useful in scenarios where timely responses are critical. For example, in a real-time messaging application, setting a deadline ensures that the users, they receive responses quickly and without experiencing delays. So if the user is not receiving the response back quickly, the client will then just time out and the messaging application will show some exception to the user. The user will not keep on waiting indefinitely for the response. gRPC deadlines, they also help manage network resources efficiently by preventing connections from being tied up indefinitely waiting for a response. So if due to some reasons the connections, they are not getting the response back, the network resources will then release these connections. So ultimately, gRPC deadlines, they help improve the overall performance and responsiveness of the client-server communication. The scenarios that we'll be implementing for this tutorial are as follows. So we'll be having a gRPC client and a gRPC server. The gRPC server will be introducing a delay of 5 seconds. So initially, the gRPC client will not be configuring any gRPC deadline. So it will not be having any timeout. So the client, it will wait for 5 seconds and it will get the response from the server. Next, we'll be configuring the gRPC client using the gRPC deadline. We'll be having a timeout of 3 milliseconds. So the gRPC server, it takes 5 seconds to process the request. But in 3 seconds itself, the gRPC client, it will throw a deadline exceeded exception and it will not get the response. So let us begin with the implementation part. We'll be modifying the code that we had implemented for Spring Boot gRPC server streaming example. So go to this link here. So in the Spring Boot 3 gRPC server streaming example, we had implemented a server streaming gRPC and a gRPC client. The server streaming gRPC example, I've explained it in this YouTube video. You can go through this. For implementing gRPC deadline, we'll be modifying the source code that we had developed for this streaming tutorial example. So go below. Here we have the client as well as the server code. Download both the examples. Import both the server as well as the client code that we just downloaded as Maven projects in Eclipse. Next, we'll be building these projects. So go to pom.xml, run as Maven build, and here use the command eclipse clean install. Run a similar command for the client. This will build our projects. So here in source main proto, we have defined the proto file. In the gRPC server streaming example that we had created before, we had created a gRPC client and a gRPC server. The gRPC client, it needs the transaction details of a particular account number for the last 30 days. So it sends this request to the gRPC server. The gRPC server then processes this request. Now the response for this request, that is the transaction details for this particular account number of the last 30 days, it is very large. So instead of sending a single response, the gRPC client, it needs the transaction details of a particular account number for the last 30 days. So it sends this request to the gRPC server. The gRPC server then processes this request. Now the response for this request, that is the transaction details for this particular account number of the last 30 days, it is very large. So instead of sending a single response, it sends the transaction details as streaming data back to the client. So if we go back to our projects, in source main proto, we have this proto file. So we have the same proto file at the server as well as at the client end. So let us have a look at this proto file. So we first have the message account request. So this is the request that is sent by the client to the server. It has two fields. First is the account number. That is the account number for which the transaction details are required, and duration in days, that is for how many days the transaction details are required for this particular account number. So this account request, it is sent by the client to the server. The server then processes this account request and returns back the transaction detail list, that is the transaction details for this particular account number for the duration in days specified. So the transaction detail, it consists of the transaction ID, the transaction type, that is whether it is credit, debit or some other type of transaction, and the transaction amount, that is the amount for which this transaction has taken place. So at the gRPC server, we'll be having a service named transaction service, which will have a method named stream transactions. It takes the account request as the input parameter and returns back a stream of transaction detail list. So if you go to source main Java, in the service package, you have the transaction history service. So in transaction history service, we have a method named stream transactions. This is the same stream transactions method that we have defined in the proto file. So this takes the account request as the input parameter, and based on this request, it will fetch the transaction details. For this example, we'll be mocking the transaction detail list that is returned back as streaming data. So in the transaction detail list, we'll be returning back 5 transactions. So we first return back 3 transactions. So here the batch size is 3. So here we first return back 3 transactions as streaming data. Then using thread.sleep, we have a delay of 5 seconds. And then the remaining 2 transactions are returned back as transaction detail list and streaming data. So let us start the gRPC server. Right click on this class, run as Java application. This will start the gRPC server on port 8090. So here it has started. Next, let us have a look at the gRPC client. Go to source main Java. You go to the transaction service client. So in the transaction service client, we make use of the async stub to make a call to the stream transactions method of the gRPC server. So here we are calling the stream transactions method of the gRPC server, and we are passing the account request to it. Once we make the call, since we are getting back the streaming data as a response, so using the stream observer, we are continuously listening for incoming streaming data. So in the onNext method, once we receive the transaction detail list, we just print out the list. When the entire streaming is complete, the onCompleted method will be called. And if there is any exception during the streaming, then the onError method will get called. So let us test this client. Run this as a Java application. So here we got back 3 transactions. It waits for 5 seconds. And then we receive the remaining 2 transactions. So let us now go to the gRPC server end. And here instead of a sleep of 5 seconds, I am giving it of 50 seconds. Stop it. Let us now start the gRPC server mode. So here the gRPC server, it has started on 8090. Let us test the client again. Now the client will receive the first 3 transactions, and then there will be a delay of 50 seconds. In some scenario, it may happen that something wrong has gone at the gRPC server end, and the gRPC client, it is still waiting for the response from the gRPC server. So we do not want the client to wait indefinitely to get a response from the gRPC server. So this is where we'll be implementing a deadline at the gRPC client end. So stop the gRPC client. We'll keep the gRPC server running. Go to the transaction service client. Here for the async stub, we'll be specifying the deadline using with deadline. And here specify a deadline. And we want the client to wait for 5 seconds, suppose. So here I just give it as 5. And here specify the units as milliseconds. So now the async stub, it will wait for a maximum of 5 seconds for the server to return a response. If it does not return the response, it will throw an exception of type deadline exceeded. So let us try this code. So let us now test the client with these changes. Run as Java application. So here the time unit, I should be specifying it as seconds instead of milliseconds. So let us now test the client again. Run as Java application. So here we have received the first 3 transactions. Now the server, it has a delay of 50 seconds, but after 5 seconds, we get an exception at the gRPC client end that the deadline it has exceeded. So the timeout period for the gRPC client is 5 seconds that we have configured using deadline. Hope you have understood this tutorial. You can download the source code for this example from here. Thank you.